Yeah, g'day YouTubers, Tinker O'Toole with another video. Hope you enjoy the video today. Please subscribe to the channel. Any comments, thumbs up. Thanks for watching. Bye for now. Yeah, g'day YouTubers. This is Tinker O'Toole again with a Raker adjustment video. So today we're going to talk about the two different methods that can be used. The conventional type constant depth gauge and the progressive depth gauge on the right. Now, the constant depth gauge was invented by Joseph Burford Cox in Portland, Oregon back in the early 50s. It looked very similar to this. It was about the same length, but it had a little gap at each end, 20 thou at one end and 30 thou at the other, so a hard and soft setting. This type of gauge is still being used today, manufacture this constant depth gauge, but it has a few extra little windows for angles, so it's very functional. Problem with this type of gauge is once your chain wears down about halfway and your tooth gets smaller and smaller, the geometry changes. Now, when the geometry changes, the attack angle changes. When all this happens, this 0.65 of a millimeter, so if we were to zoom in, this type of depth gauge here, you'll see stamped on there, it says 0.65 of a millimeter. What they're referring to is that the height of the depth of the Raker will be 0.65 of a millimeter below the highest point of the tooth. While this is okay in the beginning of a brand new chain, as the chain wears down to about halfway, you really need to be removing more than 0.65 of a millimeter. Why am I saying that? Why do you need to remove more? Because this is what you call a pivot point here. So when a chain goes around, you'll notice that the tip of the tooth is right in front of this pivot point. And if we tilt the tooth up a bit, you'll notice that's the end of the life of the tooth. And therefore the point of the tooth is now behind the pivot point. Why is the pivot point so important? And also when you file a tooth down, roughly this distance on a 3/8 chain, standard 3/8 chain, this distance between here is approximately around about 6 millimeters. By the time you wear down to this point, you're over 14 millimeters. So you've got a 14 millimeter gap. The geometry's changed, the attack angle. This is referred to the attack angle. What the attack angle means is the angle between the Raker and the top of the tooth is referred to the attack angle. What the attack angle means is that as the chain comes around and it strikes a bit of the timber, it pushes down like that, and this Raker will inhibit any further depth that the tooth can penetrate the timber. So you have this rocking motion as the chain is traveling along. So we use a Raker gauge tool to set the depth of the Raker. This type of gauge, as I said, works okay up to about halfway, because by the time you wear down, as I've previously explained, all the geometry is changing. The tooth is half its length. Its attack angle is totally different unless you maintain that with a Raker gauge tool or a depth gauge tool. And as I said, this type of depth gauge tool is limited in its capacity to give 100% efficiency attack angle and cutting angle. Attack angle and depth of the Raker are two different things, but they go hand in hand with each other. One can't exist without the other. So there's two things there, but we're not talking about attack angle, but I wanted to make you aware that what an attack angle was. Now, this type of gauge, constant depth gauge, as I said, is referred to constant because it can only ever remove 0.65 of a millimetre. It sits on 4 teeth. If, however, those 4 teeth are a little bit uneven, that gauge will not sit perfectly horizontal flat. It could tilt to the left, or it could tilt, it could tilt up or down at this end. If it tilts up or down, that will also mean that the depth will be inaccurate. Not by a massive amount, but nonetheless, it still has an effect, and you can be inaccurate using this gauge. So this type of gauge got superseded back in the early 60s by Ray Carlton, who invented and put a worldwide patent on the Philo plate. That was his depth gauge tool. Still, in their wisdom, by a lot of pressure for some of the arborist groups, started to make this type of gauge only since 2017. They did have, I think it was FG, could have been FG4 or something, or FG5. They had a file roller guide that had little depth gauge tool that was on there that was progressive like this. Wasn't the same as this, but it was sort of a lot of similarity. So still, just use the technology that Ray Carlton, everyone else copies off everyone else once the patent expires. So still release this one. The best part about the still ones, they're hardened, much harder than, say, the Husqvarna ones. The Husqvarna ones are not hardened to 62 Rockwell, a lot softer. Because these are hardened to 62 Rockwell, it actually means that you can run the file over the top of them. The Oregon ones are only made out of soft metal these days. They used to be hardened. They're only made out of really soft metal, so you can't run the file over them. They're a checking gauge. They're not really a gauge that you can use to run the file over the top. You can run the file over the top of these, and all you're going to do is scratch it. I've had these for a couple of years and never had a problem. So I just finished, as you can see, there's all filings everywhere here. And I finished filing this chain up, and it was time to check. With this type of gauge, it can be left in place, sits over the top. If any metal from the Raker itself protrudes through the Raker gauge tool, then it's just a matter of getting the file and running that over the top. Pretty simple, straightforward. But as I said, this type of gauge is old technology, and you really don't want to be using it. So that's that. So then we're left with this type of one here, and it sits over the top, the back of the gauge. We'll just see if we zoom in there so that you can see it. The back of the Raker gauge tool, the tooth sits there, and the actual Raker will protrude through the window, and the little fork that you see will sit on the tie straps. So the whole idea of this, that you sit it in that position like that. You've got two settings, hard and soft, for hardwood and softwood. So if you've got hardwood, you can use it on this setting and you run the file straight over the top. And if you've got softwood, you sit it exactly the same and run the file over the top. And it's the same thing with the next tooth. You sit it on top like that there and run the file over the top, and on the other tooth. So you just keep going tooth after tooth. As I say, you've got the soft and hard setting. And also, if you're on the left tooth, you'll put the gauge on the left side. So you can see that there. And on the right side tooth, you'll sit the gauge so the Raker sits on the right side of the Raker tool. So that's the progressive depth gauge. It really is superior. It will remove up to 1.2 millimeters off the Raker by the time you get to the little tiny triangle that's on the corner. So end of life of the chain, you won't be removing 0.65 of a millimeters, or let's put it another way. This type of gauge here will only ever, the Raker will only sit 0.65 of a millimeter below the highest point of the tooth. Whereas when you use this type of progressive depth gauge, by the time you get to the end of the life of the tooth, the distance will be 1.2 millimeters. And the reason that it needs to be 1.2 millimeters is because, as I explained before, that the tooth becomes very, very sensitive. By the time the tooth wears right down the back here, this pivot point is so sensitive, the moment that it slightly touches a bit of timber, it'll just kick back like that. So it won't be able to take a large bite out if it was only set at 0.65 millimeter compared to 1.2 millimeters. At 1.2 millimeters, it's going to take a nice sized chunk of timber out, as what it would when the chain was brand new. And that's why it's called a progressive depth gauge, because as you slowly file that tooth down, that depth increases from 0.65 of a millimeter to 1.2 millimeters by the time you get to the end of the life. And that's the reason why it's superior. Now, there's a lot of people out there that don't even check their rakers, and they wonder why they can't cut wood. You'll find out that most professionals out there will definitely use one of these gauges. Now, there's an old myth going around saying, and people use digital calipers, and they're measuring the teeth, the left and the right. From an engineering point of view, when you tell somebody, make sure that the teeth are equal left and right, and then the rakers can all be set at the right height. While that is technically true, it's not the most practical way of doing something, because you'll find out when you're using your chainsaw in the field out there that you might find out that one tooth becomes more blunt than the other or slightly damaged, and you may have to file more metal off one tooth. So if I was to damage 2 or 3 teeth and just say it was 1.5 to 2 millimeters damage, I'm not going to file every single tooth and remove 2 millimeters off every single tooth. That's what they're telling you to do, try and keep them all the same length. If you've got a couple of teeth that are out, you're not going to have an issue. It's not going to cut crooked. But let's just say that you file, I file with my left hand and my right hand, because you've got left-handed teeth and right-handed teeth, so I can just swap. It's not a problem. So therefore, you might find out I might file stronger in my right hand, because I'm a right-hander and someone's a left-hander. So you find out sometimes that some people are sharpening the left-hand tooth more, or removing more metal off the left hand than the right hand. And if they're not checking their rakers, then sure, it can cut crooked. And that's one of the reasons that the companies out there, the big chainsaw or chain companies, telling you make sure that everything is kept the same length. Because sometimes when you tell people to do something, they do the opposite, or they just don't follow the instructions. So that's why you're told to file and keep them the same length, because if they tell you to do it any other way, people just stuff things up. So what I'm telling you now, for the advanced users that have much better knowledge, is that your teeth can be different lengths. It really doesn't matter what length that they are. What is important, that if they are different lengths, that you use a progressive depth gauge, which will set the amount of bite that it can take. So in other words, if I open my mouth to bite a nice cream cake, and my mouth is only set so that it can open halfway, I can only take a half a bite, as opposed to open my mouth fully and taking a large bite. So if we use a progressive depth gauge and we set in each individual tooth irrespective of the length, that will mean that each tooth will take the same bite irrespective of the length of it. Now, this has been proven before, but as I said, from an engineering point of view, you would be telling people, yes, to keep them the same length, because from a technical point of view, they are correct saying that if you keep them the same length and you keep the rakers at the same height, it will cut perfectly straight. Everything's even and balanced. And that's the most important thing, that the chainsaw and the tooth and the raker relationship is balanced. If it's balanced left and right, it'll cut perfectly straight. And it can be balanced if the teeth are different lengths by using this type of gauge. You still get balance if you use this type of gauge, but it's not nowhere near as good. This is superior. And that's the most important thing. So, you may have watched a video and said, oh no, this guy, Tinker O'Toole's telling us something totally different. I'm telling you something different because there's more than one way to skin a cat, as they say. There is a different way of doing something. But from a manufacturer's point of view, if I had to tell or demonstrate, I would be telling everybody the same thing. Keep everything even. If everything is even left and right and the rakers are all set at the right height, yes, it will cut uniform. And that's what you tried to teach to people. But there are alternatives. There are alternatives in everything that we do. You just don't have to do something one particular way because somebody says this is the right way. People find alternatives. Joseph Cox, as I said, invented this type of depth gauge here, which was constant. Ray Carlton invented the progressive depth gauge, and this is the one that works really good. You can't find a lot of videos or information on this technology. You can download Carlton, the complete book. If you do a Google search, put Carlton, the complete book PDF, and I think it's about 35 pages. Doesn't talk much about these. So, yeah, you can't find a lot of information. It's a subject that's sort of, I don't know, people don't talk about it much. But the people that do know about it, and that's like myself, I learnt off other people, once you discover how good this works, and it will become part of your daily or weekly or monthly maintenance that you do on your chainsaw chain. Look, thanks for watching. Give us a thumbs up. I hope this has helped. Bye for now.